Ocean acidification is affecting just about every species in the ocean. The one that people are most familiar with is this idea that organisms or species or critters that have a hard calcium carbonate shell are going to find it harder to build that shell in more acidic waters. So these are things like abalone or coral reefs are made out of calcium carbonate, and so they're going to have a harder time calcifying and be more likely to dissolve. Although that's where we kind of started learning about ocean acidification, the effects are much more complex than that. There's some really interesting research showing that fish have a harder time making decisions, and so they get preyed upon more easily. The only solution to ocean acidification is to reduce the amount of carbon dioxide in the atmosphere. We can do that by reducing our emissions, or we can do it by capturing carbon, or whatever technology we need to reduce the carbon dioxide in the air and in the ocean. So people are scrambling to figure out what can we actually do, and seagrass conservation and restoration is this one tool that people are really excited about, because seagrasses actually use the carbon dioxide. The idea is, can they actually use the carbon dioxide enough at a really local scale that they create this little bubble of favorable water that's higher pH or lower carbon dioxide. And then you might have aquaculture or other species that are sensitive to ocean acidification that can survive in this kind of favorable bubble. So we still have to deal with the root of the problem, but it can potentially create solutions at really local scales that allow us to buy a little bit of time for us to deal with the carbon dioxide problem and figure out how are we going to get the carbon dioxide out of our atmosphere, how are we going to slow our emissions. There's two aspects of the way that seagrasses can help with ocean acidification. One is that they just use carbon, so they use it in photosynthesis and then they build it into the plants, just like a forest, right? And then seagrasses are really incredible at sequestering carbon. What that means is that when the leaves break down, they get trapped in this really muddy sediment that's right below the seagrass, and that carbon can stay there for hundreds of years. So we've measured about an inch deep in this sediment. We can still find carbon that's about 100 years old. So that's just sitting in that sediment, and so it's a really good, what we call a sink for carbon. The other thing is the aspect that I was just talking about, which is they can actually just draw down the carbon dioxide in the water column that might actually protect species that are in the really local environment around them. We know more about the sequestration. We know that they're pretty good at sequestering carbon. We know less about whether or not they really create these like favorable conditions in the water column that can protect other species. It's not the solution, it's a solution or a step towards a solution.